So if we're working with vectors, we would indicate a vector with a directed line segment or an arrow. So a vector is indicated with a directed line segment or an arrow. So we'll draw this in the notes. I have a lot of pictures in the textbook. And here I'm just going to draw an example there. The way the arrow is pointing indicates the direction of the vector, and the length of the arrow indicates the magnitude. So, direction is indicated by the way the arrow points, and the magnitude is indicated by the length of the arrow. And it doesn't matter where I position the vectors on the page. If I have a vector, another vector that points the same way and it's the same length, then those vectors are equal. So I'm going to draw another one. Pretend this is perfectly the same direction and the same length. So I'm going to do my best to draw it parallel and the same length. And if I have two vectors that point the same way and they're the same length, then I could say those vectors are equal. What we'll do is we'll use letters to indicate a vector. And so I'm going to call this one vector V. Now, I don't want to write just the V, but I'm going to write V with an arrow above it to indicate a vector. And I know sometimes in a physics class they'll use a little hat. That's okay. I'm okay if you use that. This one's vector U. Now what they do in the book, in the textbook, I'm going to put this up here. I'm going to zoom in on the book because it's hard to see this unless you look really close. In the book, they'll put the letters in bold. So if you read something in the book and it's bold, that's the vector. If they're talking about vectors, okay? They're not going to type the arrow above it, but they'll put it in bold. So in the book here, they say these are equivalent vectors. They're the same length and they're in the same direction. So on my paper, I have these two vectors, and I can write that U, vector U, equals vector V. Now you may have noticed when I put the book up here, they also had given the ones in the book some letters like A, B, C, D. So sometimes we might plot points and sketch a vector between the points, and then I could say this, vector V equals, well, it's also equal to vector U, but I could also write vector V as vector AB. So I can give the beginning point and the ending point. And those of you who've studied vectors before I'm gonna draw another vector. This one's not gonna be equal to the ones I have. In fact, I'm gonna draw it slanting down a little bit. So the beginning point here, we could call that the tip. And the ending point, where the arrow is, I might have these backwards. I'll have to look that up. Tip. I think I got it backwards. So, I'll have to look that up. Okay. Are they backwards?
Yeah, the arrow is the and
the arrow is the tip, right?
Yeah.
Yes, thank you. So I don't have to look it up. I just need to phone a friend. What's your name?
Ta.
Ta? All right. The tip and the tail. So the beginning point's tail, ending point is the tip. And also, the beginning point can be called the initial point. The tail is also the initial point. And the tip is the terminal point. That if we say initial point, the tail, the terminal point, the tip. So we have all that. Now we can add vectors. We can subtract vectors, we can multiply a vector by a scalar, and we can do this geometrically, and we can do it algebraically. So I'm going to go through that with you next.